Smallholder farmers in Nigeria lose up to 40% of their crops every year, not because they don't know how to farm, but because they lack access to timely, localized, and actionable intelligence. I built AgriClimateAIAgent to change that. It is not a chatbot, it's an autonomous agent that gathers data, analyzes patterns, and helps farmers take action. The experience starts with authentication powered by MongoDB. Farmers can create a profile, and every advisory, every disease scan, every alert is all saved to their history. The agent learns from their past interactions. Let me log in and show you. The weather engine connects to Open-Meteo API for hyperlocal data. I can use GPS auto detection, manual coordinates, or select from predefined agricultural sector across Nigeria. We get real-time temperature, humidity, precipitation, and wind speed. A 7-day forecast with daily breakdowns and seasonal rainfall trend visualized with Apex charts. There's also an interactive climate map with toggleable layers. Now, here is where the agents become truly autonomous. This is the MCP integration, model context protocol, connecting Gemini to MongoDB. Watch what happens when I run a diagnostic for maize in Kano. The agent doesn't just call Gemini with weather data. Look at the agent reasoning log. Query MongoDB for 12 months of historical disease outbreak in Kano, analyzing current telemetry against crop-specific disease threshold, checking active alerts from the system, reviewing my past advisory for patterns. All of this happens before Gemini generates the advisory. The AI now has context it will never have had from just a prompt. The results, an advisory that I can also switch languages from Yoruba to English, Hausa, Igbo, and have the advisory read them loud.
Current conditions show high temperature.
Disease detection model runs crop-specific epidemiological model. When I scan for disease, it checks current condition against known thresholds for maize, gray leaf spots, maize rust, fall, armyworm. And crucially, every scan is automatically saved to MongoDB through our MCP model. Over time, this builds a detection history the agent can reference. You've detected gray leaf spots in August for 3 consecutive seasons. This is a recurring pattern. The alert system monitors telemetry in real time. Extreme heat warning, flood alert, drought conditions, all severity coded and actionable. These alerts also feed into the agent advisory pipeline through the MCP.